Welcome back. In this video, we're going to still explore how to find the volume of the solid of revolution, but this time we're going to take it and we're going to use a different method, what we call the shell method. What the shell method does is we rotate around the axes and we find the lateral area of a cylindrical shell. And finding that lateral area, we're going to find infinitely many of them as we build from inside out, as these pictures are showing you. And we find that lateral area and we add them all up, and then that gives us our volume. Now, the beauty of this, the reason why we use it is because it switches the variable of integration. So now if you're rotating around a horizontal line, then y is going to be your variable of integration. If you're rotating around a vertical line, then x is going to be your variable of integration. What it does is it eliminates your need to manipulate the equations as much as it did before. And usually, honestly, shells produces an easier integral to solve than your disk or washers. In these problems, what you're going to be doing is you're going to find the volume of this, or excuse me, you're going to find the lateral area of the cylinder, which is given to you as 2 pi times r times h. If these are just around the x-axis or y-axis, x is going to be my variable of integration if it's around the y-axis, so that's going to be my radius. And then this is going to be the distance down to the x-axis, or it could be between two particular graphs. If I'm rotating around a horizontal line, then this is going to be y is going to be my variable of integration, so that's going to be my radius, and then this is going to be my height. If I'm rotating around a line parallel to the x-axis or y-axis, the only thing that changes is going to be this radius. That's it. The height is always going to be parallel to the axis of rotation. So here we go. We take a look in this first one. I have all this stuff going on here. And we're just taking this equation, which we saw in our last video, and it's bound by these different graphs. But this time we're rotating around the y-axis instead of the x-axis. I don't want to manipulate these equations around. When I rotate it around the y-axis, it's going to give me this kind of shape, and I've kind of drawn the cylinders for you. It would end up forming this type of shape here that I'm showing you. And so x is going to be my variable of integration. So x values, it's going to be x values as my limit. So it's still going to be 1 up to 2. So it's going to be 2 pi times the integral from 1 to 2. Since I'm going around the y-axis, the variable of integration is going to be x. So that's going to be my radius. And then my height is always going to be parallel to the axis of rotation. So in this particular problem, the height is going to be this vertical distance right there. That vertical distance is given to you by the square root of x minus 1 minus x minus 1 squared. So it would be the square root of x minus 1 minus x minus 1 squared. And that would be dx. In my second example, what I'm doing is I'm rotating, again, I'm taking this kind of equation. This would be very difficult to solve, but I'm rotating around the y-axis. I have to use shells. There's no other way of doing it. Since I'm rotating around the y-axis, my radius is going to be x. And this one's bound on the bottom side by the x-axis, so my height is just this vertical distance every time, which is going to be that equation, x minus 1 times x minus 3 squared. That's it. And so my limits of integration are 1 up to 3. So it's 2 pi times the integral from 1 to 3 of x times x minus 1 times x minus 3 squared dx. You do not know how to solve that by hand. You just put it in your calculator. Going around some vertical lines, this time I let my vertical line be x equals 5. So I'm going to be over here. The way the equation is given to me is the square root of x and then y equals 2. I don't want to change that, so I'm going to leave it alone. So the method that allows me to go around a vertical line but keep x as my variable of integration is going to be shells. So I've got to decide what the radius is and what the height is. In this particular case, the radius at any given time is going to be the distance from 5. So it's going to be 5 minus x. The height is going to be parallel to the axis of rotation. So this is going to represent my height at any given time. The top graph is 2, and the bottom graph is the square root of x. And so you would set it up, 2 pi times the integral. It would be the area enclosed between 0 and 4, x values. And it would be 5 minus x times 2 minus the square root of x. Just got to decide what your radius and your height is every time that pretty much sets it up. Just be careful to make sure that these limits of integration are whatever your variable of integration are. And then finally, in my last one, I'm rotating around y equals -1. So I'm down here, I'm down at the bottom of my graph at y equals -1. Now, based upon the way this equation is written, I kind of threw this in there as a little trick for you. Based upon this equation, x squared plus 2, it would be easiest to keep x as my variable of integration. But in this case, I wouldn't want to use shells. So even this section is on shells. There's parts of the problems I'm going to tell you is like, you can do it any way. You can use washers, you can use discs, you can use shells. You have to decide what is easiest. So in this particular case, it would be easiest to use washers. And I'm going around a negative line. I'm also going around a negative line, so I try to throw a little trick in there. So I had to decide what my outside radius is. I have to decide what my inside radius is. My outside radius is going to be, it's going to be 1 unit up to the x-axis, and then it's going to be the one that's further away is that line. So it's going to be 1 plus x plus 4. If you want to think about it as absolute value, that's fine too. I don't care. And then my inside radius is going to be 1 to the x-axis, and then plus x squared plus 2. So it's 1 plus x squared plus 2, or x squared plus 3. When I set up my integral, then, it's the integral. It's pi times the integral, because I'm using washers this time, from -1 over to +2. And it's going to be 5 plus x squared minus x squared plus 3 squared dx. One of the biggest challenges you're going to have in this assignment is to figure out which way is easiest. If you can figure out which way is easiest, then you can figure out the problem. It's really pretty straightforward. All right, I'll do some more examples in class. See you soon.